So in this problem, we actually have a car and a truck, and this there is a reason this is an extra credit problem. It's definitely a doozy. I know I put it on your original practice test as something aspirational, and I kind of got roasted for it. So, um, freshmen who are looking at this video, I apologize. This is an extra credit question, and for those of you that are feeling a little ambitious, maybe a little sassy, taking your exam, I wanted to give you an opportunity to look over the solution because I will be putting something similar, though not identical, on the real test that you will be taking with me Monday and Tuesday. And then for those of you that are in G period physics, I believe I will have a version of this problem for the students taking this for honors credit that will be very good for them to do. So, first, the car equation is pretty straightforward. It's a constant velocity car, so xc is positive 40 as the velocity times t, and it starts at the 0 mark. Now, what I'm really picturing here is, here's like the car. That's a very good drawing of a car. And here's the truck. Also, just an amazing artistic rendition of a truck. I'm good. Yeah. Okay, so this is the car. Now, the truck, this is something we don't do in this class directly. But remember how I said S can be the displacement? So I'm going to write it as delta S equals 1/2 AT squared plus UT. And I just want to remind you that this is S minus whatever S you start at, which is 1/2 AT squared plus UT. For those of you viewing in G period physics, this is how, this is another way of writing the kinematics equation that we've been using. So we can write this as 1/2 AT squared plus UT plus S naught when I bring that S naught to the other side. And this is actually the initial position, like it was before when we had constant velocity. So the equation we get for the truck is S equals 1/2 times, now since it's heading backwards, its acceleration is going to be -5 t squared. It's got an initial speed of 0, and it starts 400 meters away. So we're going to end up getting S is -5/2 t squared plus 400. Now this is where it gets very exciting. What we're going to do is we are going to set these two equations equal to each other because they meet in the same place. In other words, the position of the car and the position of the truck are the same when they meet, and they meet at the same time. So I'll actually set these equal, and I'm going to do some algebra. So 40t equals -5/2 t squared plus 400. Now I'm going to do a little bit of algebra to both sides of these equations. I'm going to multiply both sides by 2 to get rid of the 2 on the bottom. This is going to get me 80t equals -5t squared plus 800. And I'm going to go ahead and divide both sides by 5. And that's going to give me 16t equals -t squared plus 160. Now, I'm going to rearrange this because you can see, for those of you that are familiar, we got a quadratic equation here, and I want to kind of write it in a form that we're used to in algebra class. So when I rearrange this equation, I'm going to get this as t squared plus 16t minus 160 equals 0. And now I'm going to go ahead and use the quadratic formula. So that's going to give me that t is -16 plus or minus the square root. I'm hearing that German guy singing. Minus 4ac. Okay. Negative 16 plus or minus the square root of b squared, which is 16 squared, minus 4 times negative 160 all over 2 times 1. Now it turns out we're going to get two values for the time, and the one that we're going to keep is the positive value. So let me just simplify this a little bit more. T is going to be negative 16 plus or minus the square root of, and let me just multiply this out. So 16 squared is 256. And then we're going to add 640 to it because it's negative 4 times 160 all over 2. We keep simplifying. T is going to be negative 16. And the root that we're going to keep is the one that we do the adding to, because the negative root will give us a negative time, and that just will not make sense. Hang on. So when we actually go ahead and get that negative root, that's going to be about 29.93. So I'll just round that up. Yeah, I'll just say 29.9 all over 2. So this ends up being, when we simplify it, about 6.97 seconds. So there's the time that they meet. That's part A. Now let's do part B. Part B, we want the distance they travel. I'll plug this back into the truck, the car equation. So that'll be 40 times 6.97 seconds. And that's going to give me 279 roughly for the car. And that means the truck will, I could plug it back in the truck equation, but instead I'll just say 400 minus 279. And that's going to give me 121 meters for the truck. If you actually plug the number in for the truck, I think you'll also get 278 because this is really position value. So in other words, the truck will end up at the same position of the 279 meter mark, having traveled 121 meters to get there. And then let's just get the speed of the truck for good measure. So V equals AT plus U. So that means V equals 5 times 6.97 plus 0. And that's going to give me a speed of the truck. And I guess we could put a negative sign here if you want it to go backwards. So negative 34.85 meters per second. So that is question number 8. And I'll go ahead and take a look at question number 9 in the next video.